Hey Math 1B, I've got a new lesson for you. It's 7.5. So we've been talking about factoring quite a bit actually in the last several months. And I've talked to you guys about solving equations using factoring. Today I'm going to give you guys a lesson on what are we supposed to do if you can't factor an actual polynomial. Now normally you guys would do something called completing the square, but I'm going to skip ahead to something called the quadratic formula. Okay? So if you check out your notes page, I talked about this idea that every single quadratic equation can be written as ax squared plus bx plus c equals 0. And you guys saw that a lot when you did factoring, right? You guys saw when you had to factor 17x plus 4x squared plus 15 equals 0, you weren't able to factor that properly until you made it look like ax squared plus bx plus c equals 0, right? The commutative property allows us to rearrange this, right? So now we called it standard form, biggest exponent to smallest, which is the constant, right? So a is 4. A represents a number. B is 17. B represents a number. And then the c, the constant, is 15. So if you guys were to see this, you'd say, oh, A equals 4, B equals 17, and C equals 15. So that skill needs to be rock solid in your brains right now. So if you could, in this little space right here, take this quadratic equation. Quadratic just means it can be written like this. It has an x squared usually in it. Oh, it always has an x squared in it. 7x squared minus 12 plus 15x equals 2 plus 3x minus x squared. So if you guys could, take a minute, pause the video, and see if you can make sense of how would I make this look like that. So pause the video. All right. If you're confused, hopefully I'll alleviate that confusion. So we need to get the x squareds on the same side of the equation. In fact, we need to get 0 by itself, just like with factoring. So this negative x squared, in order to move it to the other side of the equation, I have to add it. It zeroes it out on the right, and then it adds to the 7x squared. There's actually a 1 in front of here, right? And then the 3x needs to be zeroed out, so I'm going to subtract it. It's zeroed it out. And then I'm going to subtract it from the 15x as well. And then I'm going to do the same thing here. A positive 2 needs to be zeroed out, so if I subtract it here, I have to subtract it there. So now I've got 8x squared. Negative 12 minus 2 would be minus 24. And then positive 15 minus 3 would be positive 12x. You got equals 0. It doesn't look, though, like ax squared plus bx plus c. We would have to rearrange these two terms. Positive 12x here, negative 24x there. Notice I didn't do the opposite operation here because they're on the same side of the equation. So if you look at this and you're like, yeah, I think I know how to get everybody to look like ax squared plus bx plus c equals 0, just like this, half the battle's over. So, if you guys are capable of doing this, yeah, we have a formula that requires no factoring. All you need to do is be able to plug into it properly, and then make sure you know how to use the calculator right. Here's the formula. Dun, 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 dun. It's a big fraction. So how does this formula work? Well, the example that I just erased was 8x squared plus 12x, I think it was minus 14, right, equals 0. What I'm saying is that if you have a quadratic equation, this formula right here, x equals negative b plus or minus, you're going to get two solutions, which makes sense, right? Factoring usually gave you two solutions. The square roots of b squared minus 4 times a times c, all that divided by 2a will get you your answer just like that. So here's how it works. The a is 8, right? ax squared. The b that's in this formula is positive 12 for this particular example. The c is going to be minus 14. So you're going to take these three values and you're going to plug them into this formula. Here's what it looks like. So x, which is our solution, equals a negative b, so negative 12, plus or minus, again, you're going to plus for one answer, minus for the second, the square root of b squared, which is 12, 12 squared, minus 4 times 8 times c, which is negative 14, all divided by 2 times 8, which is the a. Now, I know some of you guys are kind of confused right now. You're like, this is a lot of information flowing everywhere. Bottom line, though, is I can just plug everything in to figure out my two answers now. I don't need to do the x factor. I don't need to keep in mind what multiplies to this and adds up to that. I don't have to do factor by grouping. I don't have to do any of that. I just plug into this formula, and then inside the root here, I simplify that. What is 12 squared minus 4 times 8 times negative 14? I'm computing the inside here now. It's 592. So my two answers are going to be negative 12 plus or minus the square root of 592, and then you divide the whole thing by 2 times 8, which is 16. Okay. So now I just go negative 12 plus, for the plus part of it, the square root, make sure that symbol's showing up on your calculator, 592, hit equals to get a decimal, then divide that by 16. There's your first answer, 0.771. So x is approximately 0.771. There's our first answer. Our second answer is going to be the exact same thing, except I'm going to subtract the square root of 592. Negative 12 minus square root 592. Okay, hit equals, then divide it by 16. There's your second answer, negative 2.271. Let's see if we can make sense of a few practice examples. All right, so number one, what are the steps? Well, the first step is we need to get ax squared plus bx plus c equals 0. We need to put it in this format so that we can actually use this formula here. All right, so I need to move this 3x to the left. I need to zero it out on the right. So subtracting it zeroes it out. Got to subtract here. Also positive, so need to subtract here, subtract there. Zeroes it out. X squared minus 8x minus 17 equals 0. Got it. It looks like ax squared plus bx plus c equals 0 in standard form. Now, if there's nothing in front of the x squared, it's a 1, okay? So now, identify the a, b, and c. Well, a is 1, b is negative 8, that's different, and c is negative 17. So then we plug into this formula using these three pieces of information. X equals negative b. So it's negative, negative 8. What's a negative, negative? It's a positive. So it's positive 8 plus or minus the square root of negative 8. I'm going to put it in parentheses whenever I square or take any power to a negative number. Minus 4. That 4 is always in the formula, okay? A times 1, okay, times C, which is negative 17. All divided by 2A, 2 times 1. All right, and then you let the calculator carry the burden. All right, so I'm going to go parentheses, negative 8, square it, minus 4 times 1 times negative 17. Make sure you keep track of your positives and negatives, folks. 132. So the inside of the square root is 132. 8 plus or minus root 132 divided by 2. Which means you are going to have two solutions. The two solutions are going to be 8 plus root 132 divided by 2 and 8 minus root 132 divided by 2. And again, your calculator will do the work for you. 8 plus square root 132. Hit equals before you hit divide by 2. I get this decimal. 9.74, round up to the 5. The other one, 8 minus root 132. Hit equals, then divide by 2. Negative 1.745. Let's check out another example. All right, number 2. Does it look like this form? It certainly does. We don't have to do any legwork. Awesome. A is 2. B is negative 10. C is 18. Plug into this equation. X equals negative b. So again, if your b is negative already, that negative b is going to neutralize. It's going to be plus 10 now. Square rooted, negative 10 squared. Minus 4 times a times c divided by 2 times 2. So again, we figured out what's under the square root. So again, I'm just going to do negative 10 squared minus 4 times 2 times 18. And I get negative 44 inside the square root. Sorry, you guys couldn't see that last move. I apologize. Divide that whole thing by 4. Now, you guys might run into a snag every once in a while if there's a negative under the square root, okay? So if I took 10 plus square root negative 44 and hit equals, I get this thing. It says domain error. And the idea is, at least with what we know now, you guys cannot square root negative values. There are no real solutions there. So if you see something like this, the square root of a negative number, I'm gonna advise you guys at this point to say there is no real solution. So you guys can say no solution, but technically it's no real solution. You guys will see why in the next chapter, because we'll be talking about things that are complex numbers. But let's not deal with that right now. All right, so you got the basics, you got the special case. Practice a few on your own. So pause your videos and see if you can do number 3 from start to finish on your own without any errors. Okay, let's check ourselves. Step 1, I gotta get 0 by itself. So this negative 1 needs to be added to the left. Now, I know there's nothing to add it to, but I have to zero out the right-hand side here. Now I got 2x squared minus 9x plus 1. Okay, so the 1 didn't combine with anything, but it has its proper place in the quadratic equation there. So, now I identify what's A, 2, what's B, negative 9, what's C, 1. Okay, got my 3 values, plug them in. X equals a negative B, a negative 9 is positive 9, plus or minus the negative 9 squared, minus 4 times 2 times 1, divided by 2 times 2. All right, plug this value in your calculator, you're going to get 81 minus 8, which equals 74. No, 73. Should I check myself? You know what? Just because this is going out on the World Wide Web, not that I haven't made mistakes before publicly, but it's 73. Okay, there we go. So you got 2 solutions. Your 2 solutions are adding the root 73, then dividing by 4, and subtracting the root 73 divided by 4. Awesome, awesome. 2 decimal answers here. And there's no special funny business because the root is going to be a positive number. We're good in that area. All right, so la-di-da. The top answer is going to be 4.386. The bottom answer is going to be 0.114. All right. Try it one more time. Last example, number 4. Pause that video. Give it a try. Let's see if we can do it the correct way. No errors through the whole thing. Okay, here we go. We already got it by itself, so it's just a matter of A is 3, B is positive 5, C is negative 9. There we go. Now we plug into this quadratic formula. X equals the negative B. In this case, it's negative 5. Okay? So the negative stays. Plus or minus the square root of 5 squared minus 4 times A times negative 9, the C, all of that divided by 2 times A. So X is equal to negative 5 plus or minus, let's see, 25 times, let's just do that. Minus 12 times negative 9, 133. All right, then you got 2 decimal answers here. X is by the way, I put the approximate symbol because I got to cut it off at some point. I'm cutting it off 3 digits past the decimal. I'll ask you guys to do the same on your homework, please. Negative 5 plus root 133 divided by 6. That would be 1.089. Really, the squiggle should be there, not here. And then when you subtract it, using our calculator, becoming good friends, giving me the answer, always at the end, divided by 6, approximately negative 2.755. Hopefully you guys can see all that. You can see all that. And that's it. Wow, okay. So, yeah, 19-minute video. You guys had a lot of patience to get through that. I appreciate it. The quadratic formula, hey, it's a great alternative to factoring, right? Factoring baffled a lot of you guys. The quadratic formula just says, can you pick out A, B, and C? Can you plug them in this formula? Can you use your calculator properly? If you can do those 3 things, you're good. Okay, thanks for watching.